Hello everyone, this is Steve. Thanks for joining me. We're going to find the ordered triple that satisfies all three of these equations up here. So we're going to find an x value, a y value, and a z value that work in all three. So I'm going to start by numbering my equations because it's important to keep our work organized. And what we're going to do is we're going to add two of the equations together to get rid of one variable. Then we're going to add a different pair of equations together to get rid of that same variable. But in this particular problem, before we can add equations together to get rid of a variable, we have to multiply the equation by something that will make that variable go away. So I am going to get rid of the x's. So watch what I do here, everyone. I'm going to take equations 1 and 3. So equations 1 and 3. So 3x minus 5y plus 2z equals negative 10, and x minus y plus 2z equals 12. So that's 1 and 3. Now I'm going to multiply the second equation up there, which is equation number 3, by negative 3. That way when I multiply by negative 3 and I add them together, the x's will go away. So we take this equation and we multiply it by negative 3. Now watch what that does, everyone. It makes it negative 3x plus 3y minus 6z equals negative 36. But then when I add that to the equation 1, the x's will go away. So I add them together, gives me negative 2y minus 4z equals negative 46. All right, now I want to use a different pair of equations to get rid of x's again. So this time I'm going to use equations 2 and 3. So equation 2 is 5x minus 4y minus 5z equals negative 53. And equation 3, once again, is x minus y plus 2z equals 12. But this time, before I add them to get rid of the x's, I'm going to multiply equation 3 by negative 5. So watch what happens when I multiply this equation by negative 5. It's going to be negative 5x plus 5y minus 10z equals negative 60. And if I add the original equation 2 to that, 5x minus 4y minus 5z equals negative 53, I will get the x's to cancel. And what I'll get here is I will go and get a y minus 15z equals negative 113. Okay, so now I look at my two new equations. I've got negative 2y minus 4z equals negative 46, and I've got y minus 15z equals negative 113. So I'm going to add them together and get rid of another variable. So this time I'm going to multiply the second equation by a positive 2. And that way the y's will go away when I add them together. So I multiply this equation here by positive 2. So that's going to be 2y minus 30z equals negative 226. And then my first equation here was the negative 2y minus 4z equals negative 46. Okay, let's add them together. And as we wanted, the y's do go away because negative 2y plus 2y is 0. And let's see what happens here. We get a negative 34z. And over here, I'm going to get negative 272. Well, I divide both sides by negative 34 and cross my fingers, then I get a good answer for z here. And for z, you should get 8. Negative 272 divided by negative 34, you can check that on your calculator if you want, but you should get 8 for that. I now have 1/3 of my answer, and that's actually the hardest 1/3 to get. Because now you take that z equals 8 and you plug it back into any equation you have that has both y and z in it. So here's an equation right here that has both y and z in it, this equation right here. So I'm going to plug my z equals 8 into that. Y minus 15 times 8 equals negative 113 y minus 120 equals negative 113. Add 120 to both sides, and you will get y equals 7. Okay. Now we need to find x. So we need to go back to an equation that has x, y, and z in it. I will use my original equation 3. So x minus y plus 2z equals 12. Okay, so x minus 7 plus 16 equals 12, or x plus 9 equals 12, subtract 9, x equals 3. Final step, convert it into an ordered triple, 3, 7, 8. And if you have extra time, that is the correct answer, everyone. But if you have extra time, you should check that in the original 3 equations to make sure it works. I hope that helps. Thanks for watching.